about that. I forgot to give the notes out. So we are going to continue today in section 4.1. We're still graphing parabolas, okay? But now they're going to give you the equation in a different form. So if you ask me, this only gets easier because the form they give it to you in is something called vertex form. And the reason it's called vertex form is because the vertex of your parabola is literally written as 2 of the numbers in the equation. So you don't have to do any of that opposite of b over 2a and plug it in to get the y coordinate. The vertex is literally written right in the equation. So you just pull those numbers right out and start using it and start creating the graph. So it should be easier, okay? All right, so just to review a couple things with you. We are working with quadratic equations. A quadratic equation is a degree 2 equation, right? That just means that the highest exponent on a variable is 2. So these are our x squared equations, okay? Standard form is the form that we worked with that last week. Standard form of a quadratic equation looked like this. Y equals ax squared plus bx and plus c. So today, they're not going to look like that. They're still going to be an x squared, but it's not going to look like that because it's not going to be written in standard form anymore. The graph of a quadratic equation is still going to be a parabola, the U-shaped graph. The most important point on the graph is still going to be the vertex. But the beautiful thing is the vertex is going to be really easy to find now because the vertex will be written right in the equation. All right, so guys, here's the new form. This is what vertex form of a quadratic equation looks like. It's going to start with y equals a. So it starts just like standard form, but then after that, it's going to look completely different. Now this a value is still the number that tells you if the parabola goes up or down. So if a is positive, it'll go up. If a is negative, it'll go down. And if you're a pattern person, that's your pattern number still the a. All right, the rest of the formula doesn't look like this. And we don't use b and c anymore because they don't represent the same missing numbers. All right, so that's going to look like this. Parenthesis or times x subtract a number h, the whole thing squared, that's the quadratic part, the squaring, and then plus some number k. So when your quadratic equation is written like this, that means it's in vertex form. And it means the vertex of your parabola is literally the h that is in your equation is your x coordinate. And the y coordinate of your vertex is this number k at the end by itself. So like I said, when you're in vertex form, the vertex is going to be looking right at you from the equation. You just take it and start using it. All right, but there's one little catch. The formula says that it has to be x minus some number h. So really, the x and the minus, they are part of the formula. It's just the h that gets to be the x coordinate of your vertex. So guys, just to give you a little hint, in the future, whatever number is written here, it's really going to be the opposite of that number that ends up being the x coordinate of your vertex. So h is always the opposite of what it looks. And I'll explain that further in a second. That's the only thing you have to watch out for. Otherwise, guys, this is really, really easy today. All right, so guys, look at this. Here's an example of what a quadratic equation in vertex form is going to look like. So as soon as you see the parentheses, you know you're not in standard form. You must be in vertex form. Okay, so it's going to look like y equals a times x minus some number h squared and then plus k. So in vertex form, a in this example is supposed to be the number in front of the parentheses. So what number do we have to assume is in front of this parenthesis? 1. All right, h is going to be the number inside the parentheses who will end up being the x coordinate of your vertex. But guys, the formula says it has to be x subtract some number h. So some number h here is literally just 5. So the subtraction is actually part of the formula. So that means h is, it looks like -5, but it's the opposite of what it looks. It's actually just 5. Okay, because again, this subtraction sign, it's part of the formula. It's x subtract some number h. So the number h is actually just 5. And then k, the y-coordinate of your vertex, is always the last number at the end by himself as is. So +3. All right? Now this parabola, since a, the number in front was positive, will go up. And the vertex is always going to be the point hk. So here, that would be 5, 3. So again, you just take the vertex right from the equation. It's the opposite of this number, and then that number as is, every time. All right, let's look at this one. Here's an example of another quadratic equation in vertex form. So A in this problem, remember, it's got to be looking like this. A, the number in front is -2 this time. H, and here's the problem. This is why it's always the opposite. Guys, it looks like +3, right? But it's not. Because technically the formula says it has to be x subtract some number h. Well, the only way to get this to be +3 means I must have subtracted a -3. Because minus minus would have turned to a plus. So now x subtract, who's your h? It's -3. So now it's the opposite of whatever it looks every single time. All right, and then k as is -4. All right, this parabola is going to open down because the number in front was negative. And then the vertex is always the point hk. So in this problem, it would be -3, -4. The x-coordinate is the opposite of this number, and then the y-coordinate is that number exactly the way it's written. Okay? All right, let's try a couple examples and look how fast these parabolas come together when the vertex is right there for us to take. All right, so here we go. We're going to graph this quadratic equation. So in this problem, this is A, the number in front is -1. H, which is always the opposite of that number, will just be 1. And K, the number at the end, is +5. All right, this parabola is going to open down because the number in front is negative. My vertex, which is always the point hk, is 1, 5. The opposite of that number, and then that number as is. Well, guys, put it on your graph. As soon as you find the vertex, write 1 up 5. Then they're going to want the AOS, that invisible vertical line that goes right through your vertex and cuts the parabola in half. All right, the equation of that AOS is the line x equals 1. All right, well, now, guys, now you got to make a choice. Do you want to make the table or do you want to use the pattern? If you're a table person, I told you to put the vertex in the middle, and then you'll pick 2 x's to the right, which are 2 and 3, and then 2 x's to the left are 0 and -1. And then you would begin plugging them in, whichever ones you want. So, guys, just in anybody who wants to use the table, if you plugged, let's say you were going to plug these numbers in and then match it over here. You'd plug this one in first, the one right next to your vertex. It would be y equals the negative sign, and then 0 minus 1, the whole thing squared, and then plus 5. If you plug that right into your calculator and hit enter, it is the entire thing for you. All right, otherwise, let's see if we can use the pattern, and then I'll tell you what the table became. The pattern here relies on A, which is -1. So you'd need 1A, and you need 3A. I don't make you find 5A, 7A, 9A, 11A. All right, if A is -1, 1 times -1 is -1. 3 times -1 is -3. So those are the jumps that we'll be making first. All right, so go to your vertex. Go to the right one to the next x value and jump down 1 point. And then match it on the other side, or go to the left one and jump down 1. Now from this point, go to the right again to the next x value. Now jump down 3 jumps. 1, 2, 3. And then match it on the other side. And then guys, there's your parabola. Okay? So now if anybody was using the table, anybody who plugged 0 or 2 in would have gotten 4 to come out. And anybody who plugged -1 or 3 in would have gotten 1 to come out. And you would have ended up with the exact same dots as us. Okay? All right. Guys, is that all right? Everybody okay? Guys at home, we okay? Thumbs up, everybody's good? All right, then we have just the annoying questions down here. Does this parabola have a max or a min? Well, guys, it's going down, so it clearly doesn't have a low or a min, but it definitely has a highest point up there, which is a max. The y-intercept, lucky for us, I can see it. It crosses the y-axis right there at the point 0,4. The x-intercepts, our last dot is very close to where they cross over the x-axis, so we can make a pretty good guess. It looks like our x-intercepts, there are 2 of them. This one is crossing over between 3 and 4, so I'll just say 3.5, just to make a rough guess. And then this one is crossing over between -1 and -2, so I'll just say -1.5. And then I'm going to say ish, because again, we're just estimating. The domain of all quadratic equations, the x values that will eventually live on this graph are all real numbers. And then the range, the y values that live on this graph, guys, the y values are clearly on this graph all down here. The highest y value on this graph was at the vertex, which was 5. And then all of the other y values are lower than that. So that's y is less than or equal to 5. Okay? All right, let's do it again. Let's see how it feels. Because again, these should get really quick and really easy, being that the vertex is there for us to just take. We don't actually have to calculate it. All right, here we go. Look at this one. Here is a quadratic equation in vertex form. So in this problem, A, the number in front is 2. H, the x-coordinate of my vertex, is the opposite of that number, so -6. And then K, the number that's supposed to be added or subtracted onto the end, well, guys, there's nothing here. So what number do we have to assume is there to represent nothing? It would have to be 0. Remember, if they don't put something in front, we assume something in front to be 1 or -1. But if they don't put something at the back, that has to be assumed to be 0, because if they wanted to add 1 onto the end, they would have to write that. All right, this parabola is going to open up because A is 2, which is positive. My vertex is always HK, so -6, 0. All right, so put it right on your graph. Left 6, up or down, none. Let's do our AOS, that invisible vertical line that goes right through the vertex and cuts our parabola in half. That would be the vertical line. X equals, what is the x coordinate doesn't change? -6. All right, now you gotta make a choice. Do I want to use the pattern, because that's really quick, or do I want to make my table? It's up to you. If you're a table person, you put -6, 0 right in the middle. You would pick 2 x's to the right, which are -5 and -4, and you'd pick 2 x's to the left, which are -7 and -8. And then you can either plug these in and match them, or plug these in and match them. Otherwise, let's use our pattern. A is going to be 2 here, so let me get my 1A and my 3A ready. 1 times 2 is 2 jumps. 3 times 2 is 6 jumps. And this parabola should be going up because A was positive, so they should be positive jumps. All right, here we go. So from our vertex, go to the right one to the next x value, but jump up 2 spots. and then go to the left and jump up 2, or just match it on the other side. That means anybody making a table, if you plugged in -5 or -7, you should have gotten 2 to come out. All right, and now go to the right one again to the next x value, but now we're going to jump up 6 spots. 1, 2, 3, 4, 5, 6. And that's 2 away, so then 2 away over there. You can match it on the other side. And there's your parabola. So anybody making the table, if you plugged in -4 and -8, you would have gotten +8 to come out.
Wait, sorry.
Yes?
I don't use the patterns. Why do we pick 1 and 3?
Where do you, here?
Yeah, so
It just happens in like a freak of nature thing. Parabolas climb following the pattern 1A, 3A, 5A, 7A, 9A. So we haven't picked them. It's literally the pattern that a parabola will go up by. That's why we use them. Okay? All right, max or min? Well, this one is going up. So there's clearly no high point, but there's definitely a low point. So this one has a min. All right, the y-intercept. All right, guys, unfortunately, we cannot see where the graph is crossing over the y-axis yet. It's going to be somewhere way up there. Since we can't see it, we're going to have to calculate it. We know that to be a y-intercept, your x-coordinate has to be 0. So we're going to plug 0 in to see what number comes out, and that's how we'll find our y-intercept. So if I plug 0 in, that'll be y equals 2 times 0 plus 6, the whole thing squared. Type that into your calculator and let it do the whole thing for you. It's going to be 72. It does not cross over the y-axis until y is positive 72, so all the way up there. All right, so the y-intercept is x is 0, y is 72, so it's big. All right, the x-intercepts, the roots, right? Guys, there's only one. It only crosses or touches the x-axis one time, and it's right there at our vertex. So the vertex is your root. It is your x-intercept. There's just one of them. All right, the domain. The domain of all parabolas and quadratic functions is all real numbers, right? All x's are going to live on this graph eventually. And then the range, the y values, guys, the y values are all up here. But the lowest y value is 0. And then all the other y values are bigger than that. So y is greater than or equal to 0. And you're done. Everybody okay? Again, hopefully, I know the bottom questions are annoying, but hopefully putting the graph together got a little bit easier because getting the vertex is so much easier now. It's just in the equation. I don't actually have to calculate it. Okay, for the last example, I just want you guys to understand that not all parabolas are this beautiful. They don't all have these beautiful whole number coordinates. Sometimes the vertex and the other points on the parabola, guys, they're ugly decimals and fractions, all right? I try to avoid those ones, but they do exist. They're not all beautiful and perfect. So I just wanted to show you one so you could handle it in the future if it wasn't the prettiest numbers involved, all right? So look at the last example. So right away, you guys normally have like a physical reaction to this. You see the fraction and you get really angry, all right? I get it. Fractions, you don't like them, but guys, they're a part of our math class, okay? So my suggestion is when they're gonna let A, that number in front, be a fraction, or any other part of it is a fraction, I just suggest everybody be a table person. Don't worry about the pattern because it just means the pattern, you might have to jump like fractional jumps or decimal jumps, and maybe that'll be hard to count. So I just suggest that if it don't look that pretty, everybody just use the table and let the calculator do all the hard work, okay? All right, here we go. Here's a quadratic equation in vertex form. A, the number in front is -1/4, which ultimately, we just care about the sign, right? It's negative, so now we know if it's going up or down. H, the x-coordinate of my vertex is the opposite of that number, so -2. And K, the y-coordinate of my vertex, is always this number at the end, as is, so +6. Okay, this parabola is going to open down because A was negative. So we got a visual. The vertex is always HK. So that's -2, 6. So let's put that on our graph. Left 2 and up 6. All right, let's get our AOS, the invisible vertical line that goes right through our vertex and cuts the parabola in half. That'll be the line x equals, what is that x coordinate? -2. Okay, so normally when you get here, it's like, all right, do I want to use the pattern or the table? I think everybody should use the table. Otherwise, you're going to be doing 1 times a, 1 times -1/4. So you're only going to jump down 1/4 of a point. Then you're going to be doing 3 times -1/4. Then you're only going down 3, -3/4. It might not be easy for you to count. So just use a table. Let the calculator do it. All right, so let's put our vertex in the middle. -2, 6. Let's pick x's 2 to the right, so -1 and 0. And let's pick 2 to the left, so -3 and -4. And then you pick, who do you want to plug in? I'm going with -1 and 0, and then I'll match it to the other side. So I like to plug the one right next to my vertex in first, -1. So guys, this is what I'm going to do. Y equals -1/4, right? I just do this, parenthesis, -1 divided by 4 and close it. And that's my -1/4. The parentheses will hold it together, so I like to write my fraction like that. Then I do parenthesis. I'm plugging in a -1, so -1 plus 2, parenthesis, squared, and then plus 6. If you type this into your calculator, it'll do the entire thing for you. Hit enter, and you should get 5.75. So it's not a terrible decimal. So that means -1 and 5.75. All right, and then I can match it 1 space away from the AOS on the other side. So that means anybody who plugged -3 in would have gotten 5.75 to come out as well. All right, now let's plug 0 in and see what the next number is. So -1 divided by 4 in parentheses, that's my -1/4. And then parentheses 0 plus 2, parentheses square, plus 6. Hit enter, does the whole thing for you. This one's actually not bad. It's 5. And then I find out that 0,5 is a point. And since that is 1, 2 spaces away, 1, 2 spaces away on the other side is that matching point. So anybody who plugged in -4 would have also gotten 5 to come out. All right, now we just connect our dots. Now, usually what happens when A is a fraction, normally your parabola is pretty wide. It's like fat almost. I don't like that word, but it's chubby. All right, it's wide. All right? And it looks like that. Okay, is that all right with everybody? Yes? So again, my advice is just, if A is a fraction, use a table. All right, the annoying questions, max or min? Well, guys, clearly it's going down, so there's no min, but there's definitely a high point right there, so that's a max. All right, the y-intercept. Oh, thank God, it's right there. It's 0,5. All right, here's the problem with the x-intercepts, the roots. Guys, do you agree? This parabola is definitely going to keep going, and it's going to cross the x-axis 2 times. Here's my dilemma. Normally, when we estimate the x-intercepts, it's because our last dots were usually pretty close to the x-axis so that I could estimate where they are. My last dot is pretty far away from the x-axis. So once I start doing this, everything that I do here is a huge estimation. So right now, according to mine, it's crossing in between 3 and 4. But maybe it ended up crossing in between 5 and 6. Or maybe it ended up crossing between 2 and 3. And I just can't see it because of how far away my last dot is. So all I want you to do is, we know there's going to be 2 of them. So I want you to say there are 2 x-intercepts or 2 roots. But right now, as far as what they're going to end up being, we are undecided. We are too far away to make a really good guess. Now, normally, when we don't know what the y-intercept is, right, we just plug x's 0 in and see what number comes out. If we wanted to solve for the x-intercepts, I'd have to solve for x when y is 0. So I'd have to plug 0 in for y and then solve for x. But I have not taught you how to solve a quadratic equation yet when you send it equal to 0. So we can't solve for it yet, okay? That's why we can only estimate. And if we can't estimate, we have to be undecided. But we can at least see there will be 2 of them. All right, the domain is always all real numbers. All x values are going to live on this parabola eventually. And then the range, the y values, guys, they're all down here. The highest y is 6, and then the rest are smaller. So y is less than or equal to 6 is your range, okay? All right, how'd that feel, guys, okay? All right. Everybody at home, thumbs up, are you okay? Okay, so again, hopefully this feels easier because it's a little bit faster than last week. All right, for homework, I have to apologize. Your homework tonight is on quizzes. It's 20 questions. I don't think I've given you 20 questions yet, but in my defense, the majority of the questions are multiple choice and really, really fast, like definitions, like does this parabola open up or down? Does this parabola have a max or a min? So it's really, really quick questions. So it shouldn't feel that long, even though 20 questions sounds very long, okay? But it's not due until tomorrow at 11:45 at night, okay? All right, if you have any questions, please let us know. Is the attendance all good? Yep. All right, so guys, you are good to go if you have no questions, and we will see you tomorrow.